Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin. I'm going to cover limits of multiple variable functions. And I'm going to do a Calculus 1, Calculus 3 approach like I did in a previous video. So let's kind of get at it. Calculus 1, when I ask you to take the limit, we know that we have multiple methods, but we're going to do this algebraically as opposed to using L'Hopital's rule, because I'm going to do, Calc 3 limits algebraically. So the way we do it algebraically is we factor, and then we see if we can cancel off a common factor to where, this thing was essentially undefined. So one thing you can always do when trying to find a limit is you could plug this thing in. Now, if I plug in 3, we're going to see the top will be equal to 0. 3 squared is 9, plus 3 is 12, minus 12 is 0, and then also you can see the bottom is 0. So this will be 0 over 0, which gives you good evidence that they share a common factor where, this function here is, is undefined or indeterminate. So factor the top, I can see that this is going to be an x plus 4 times an x minus 3. So I can see that these will multiply to negative 12 and these will add to positive 1. So when I FOIL it, we see that we get that numerator. And this is a difference of squares. So this is going to be x plus 3 times x minus 3. Now they have that common factor of x minus 3, which is where this thing was undefined. So when you factor out that common factor, this new function is now defined at 3. Which means we can now evaluate it at 3. So this would be equal to 3 plus 4, all over 3 plus 3. So we can see that this limit is going to be 7 over 6. Now similarly, when we get to Calculus 3, we're going to do the same thing. We're going to factor the top, we're going to factor the bottom. Now the way this thing factors, this numerator factors, is, let me give you kind of a hint. If I have x squared minus 6x plus 8, for instance, if you can factor this trinomial, you can factor this trinomial. This factors into, an x minus 4 and x minus 2. And what we'll see is when I factor this numerator, that I'm going to get a x minus 4y times an x plus 2y. You see that we have like the same coefficients here. Except when I multiply these lasts, we can see that we're going to get, this should be a minus. When I multiply the last, I'm going to get a positive 8y squared, which is here. And when I do outside, I'm going to get a minus 2xy, and then a minus 4xy, which is going to give a minus 6xy. And of course, the first are still going to be equal to x squared. So if you can factor this trinomial, you can factor this trinomial. And very similar for the bottom. Our denominator is nothing more than a difference of squares. So x plus 2y times x minus 2y. Now, the first thing we would try to do and find the limit is I try to plug in this 2 comma 1, and we'll see that we'll get 0 over 0 again. So when I factor the top, factor the bottom, I can see that this common factor right here, well, if x was equal to 2 and y was equal to 1, this would be equal to 2 minus 2. So this is why you get 0 over 0s from that factor. So once you cancel that factor, this new function is defined at x equals 2, y is equal to 1. So we're just going to plug that in. So x is 2 minus 4 times 1. And then the denominator is going to be 2 plus 2 times 1. So we're going to get negative on the top 2 over 4, or we'll get negative a half. So let's do so the last example is similar to, example A is going to be another rational expression where I have a polynomial over a polynomial. And again, we'll try to plug in 0 comma negative 4, and we'll see that we get 0 over 0. So let's factor it and see what factors make it 0 over 0, and hopefully those things will cancel and the function will be defined, at that point 0 comma negative 4. So the limit as x comma y approaches 0 comma minus 4 in this thing's domain space is going to be, well, factor the top's not too hard. If they share an x, I'd be left with a y plus 4. Now the bottom is a 4-term polynomial, and we factor these things by grouping. So you look at the first two and see what they share. Well, those share an x comma y, x times y, and I'd be left with, factor out an xy from here, I'd be left with an x, and xy from here, I'm left with a minus 1. Now similarly, I'm going to see if those things share something. So they share a 4x, and I'm left with, I'll be down another x minus 1. So, looking at the denominator, because the numerator is already factored, I can see that these have two terms. This is a term separated by this plus, which this is a term. So they share an x minus 1 in each one of these terms. So when I factor out an x minus 1, I'd be left with an xy for this term, and then for this term, I'll be left with a 4x. Now continue with the bottom, because we're on a roll here. This still shares an x, so if I factor out an x, I'd be left with x minus 1 times y plus 4. And then the top, we already know it was these two factors. All right, so the limit as x comma y approaches 0 comma minus 4. And what we can see is that this function is now defined at that particular point, because when x is 0, that was what made 0 over 0, and also when y was negative 4, this would also be that 0 over 0. So once those things cancel, this 1 over x minus 1 is now defined at this point. So plug it in x equals 0 and y equals negative 4. This would be equal to 0 minus 1. There are no y's left. So this is going to spit out the answer of negative 1 for its limits. For this example is, in calculus 1, I have the limit as, say, x approaches root 5 of this ratio expression. So I know I can't plug in root 5 because I'd have root 5 minus root 5, so the bottom is going to be equal to 0. And if I plug in root 5 at the top will also be equal to 0. So this looks like it's going to, factor like what we had before. But since it has radicals, the trick for radicals is we multiply top and bottom by the conjugate. Now, the conjugate of what? Well, the denominator is the one that has the radicals, so we're going to do the conjugate of that. So the conjugate of x minus root 5 is going to be x plus root 5. Then we'll see what happens. So this is going to be equal to the limit as x approaches root 5. Now the denominator, when I FOIL x times x, is x squared. Outside and inside will cancel. I have a root 5x and then a minus root 5x, so that'll be 0. And then minus root 5 times positive root 5 is going to be equal to a minus 5. Now we're not going to FOIL the top because it's this x squared minus root 5 that I'm trying to cancel. I can see that's what I got in the denominator. So things that are not conjugates, we just leave them in this factored form for multiplication. Just to multiply the, this times this. Now what we can see is that, this x squared minus 5 cancels, and this function now is defined at root 5, so I can plug in root 5. So root 5 plus root 5 is going to be equal to 2 root 5. Now, similarly, when we work with, a Calc 3 problem, it's the same methods. We're just working with multiple variables, so the cancel, the simplified will feel very familiar. So I can see that the top's the one that has the radical now, so we're going to multiply top and bottom by the conjugate. This term minus this term is going to be this term plus this term, which is going to be its conjugate. So what you do to the numerator, you must do to the denominator, because I have to multiply by this special factor of 1. So we will multiply the numerators because those things are conjugates. So the limit as x comma y approaches 2 comma 0 in this thing's domain space. We also say, the denominator can't be 0. That's why they say this. But it's going to become less relevant when we simplify these things. So when I multiply here, because the conjugates will multiply together. So first, root 2x minus y times root 2x minus y would be equal to root 2x minus y squared, thus annihilating that radical. So this is going to be 2x minus y. Now very similar. Outside is going to give me 2 of this radical. Inside is going to give me negative 2 of that exact same radical. So those will cancel just like what happened here. And then finally when we do the last, 2 times negative 2 is going to be equal to minus 4. Now in the denominator, these are not conjugates, so we just write them, their product, in this factored form. And we will see the reason why we did that is because when you plug in x equals 2 and y equals 0 into, this expression here, you know that you're going to get 0 on the bottom, but boom, they cancel. So now we're going to be, 1 over this expression. So this is going to be 1 over, and now let's see if I can plug in x equals 2, y equals 0. Well, this would be the square root of, 2 times 2 minus y, which is equal to 0, plus 2. So this is going to be root 4, which is going to be 2. So this is going to be 1 over 2 plus 2, which is going to equal 1 over 4. So the last limit I want to do is something we saw in Calculus 1, and we know that the limit as x approaches 0 of the sine of 5x over x. Well, what we're going to do is we're going to use this trick over here, is that if I have the limit of theta goes to 0 of the sine of theta over theta, we know that this is equal to 1, and we can verify this using L'Hopital's rule, but I want to do it algebraically. So really what I have to say is that the angle inside the sine has to match, this denominator, and these things essentially have to be going to 0 at the same speed is the layman term saying that. So right now that, this is going to be the sine of 0 over 0, so I still get this expression of 0 over 0, but unfortunately, these do not match. They need to. They have to match in order for this to give us the expression 1. So if I have a 5x here, I need a 5x down here. So what I'm going to do is I'm going to take the limit as x goes to 0 of, the sine of 5x over x, and I'm going to multiply outside of this expression by 5 over 5. See students try to factor out this 5. It's not. It's inside the angle. The only multiplication here is the 5 times x. So the best I can do is just multiply it by a constant. So this is going to be equal to 5 times the limit as x approaches 0. I can take this 5 which is, basically 5 times a fifth. I can take the fifth and distribute it into the sine of 5x over x. So this is going to be equal to the sine of 5x multiplied by 5x. And you can still see that I have that multiplication of 5 over 5 there. Now that I have the sine of its angle over, the exact same thing, we can see that these now match. These really are acting like your thetas, and those are going to 0, which means this entire expression here is going to 1, so this is going to be equal to 5 times 1, which in turn will be equal to 5. Now in multiple variables, we still have that same thing. I'm taking the limit as x comma y goes to 0 comma 0, so I can see that this is the sine of 0 over 0, so this will be 0 over 0. But I need these, I need the argument to match this, well, the argument, the angle to match this denominator. So what I'm going to cleverly do is I know I can multiply x minus y times something that'll give me an x squared minus y squared, and here I'll show you what I'm going to do. So if I have an x minus y, if I multiply this by x plus y, I know that that's going to give us a difference of squares. First is going to be equal to x squared, outside and inside will cancel, then I'm going to have a minus y squared. So what I'm going to do to this is I'm going to multiply top and bottom by x plus y over x plus y. And this is going to be times the limit as x comma y approaches 0 comma 0 of, the sine of x squared minus y squared all over x minus y. Now, distributing the denominator into here and leaving the numerator of this thing out, I'm going to have, this x plus y, multiplied by the limit, let's leave it like this, multiplied by the limit as x comma y approaches 0 comma 0 of the sine of x squared minus y squared. And I already did this product right over here. You can see that this is going to also be, x squared minus y squared. And what I can see is that now these match. These are your theta over theta, and they are both going to 0 essentially at the same speed. So that means this entire expression is going to limit to 1. Now, remember that x comma y is going to 0 comma 0, so I'm really going to put this inside of here as well. So let's do this. So this is going to be the limit as x comma y approaches 0 comma 0 of x plus y times, the sine of x squared minus y squared all over x squared minus y squared. And what I have is the limit of the product is the product of the limit. So, this piece here is going to go to 1. And then when you plug in 0, comma 0, this is going to be equal to 0 plus 0 times this 1. So this is going to equal 0 when we're done. All right, so if you like the content, please subscribe.